Hello all. So guys, we will be discussing about fake news classifier, and this is specifically for the members. So I'm sorry I could not upload for some days regarding some videos on projects because I was having a lot of office work. But anyhow, we'll continue and we'll try to actually implement this because many of you people had actually requested for fake news classifier and how do we solve this particular problem. That is like how do we develop an application which will be able to solve this particular problem. Now, the best thing is that I'm going to cover both machine learning and deep learning in this particular video. I'm going to try with two machine learning algorithms which work pretty much well, and we'll be discussing about that. First of all, from where did I get the data set? It is definitely from Kaggle. So if I just go to this particular website, you'll be able to see all the data set available over here, and you can actually download it. Anyhow, I'll be giving all the data sets again in my GitHub, or you can also download it from here, right? So let us go ahead and try to understand how to actually solve this particular problem. Now, the first thing is that, guys, we are not solving this competition right now. So I will probably take only train data set. I'll try to split them into train and test. And then we'll try to see what is the accuracy that we are actually getting, because we should need some output levels to verify the test data, right? So first, if I just go over there is one folder. So if you download this data set, you'll first of all have a folder called as fake news, and then you will have train.csv. So I've given the same folder. Okay, make sure that you also set up the same folder. And then I'm reading the data set. After that, I go and see the head. In head, you'll basically be having ID, title, text, label, right? And author. So label is my output feature. Text is basically my independent feature. Author is also independent feature, or title is also independent feature. So what you can do is that I'll probably be taking text, because in text only we are having more number of words. So I'll be considering this, and I'll try to create a classification problem. And again, the label is just 1 0. So again, I've also found out a data set which has 3 category labels. You can also apply multi classification problem, but whatever algorithm we are discussing, it will also work for multi classification also. Now, the first thing is that I'm just getting all the independent features. I hope everybody knows how to do it. I'm just dropping this label column from axis is equal to 1, that is column is equal to 1, right? So df.drop label axis is equal to 1. So this is my x dot head, and I'm getting the dependent feature by just using df of label, right? Df of label, and I'm getting it over here as my y variable. So let me just quickly execute this in front of you so that you'll be able to see how things runs over here. And probably if you get any error, that also I'll discuss about here. So here it is. So I'm just implementing this. This is my x dot head. Now you can see that I don't have that label column, and then I'm going to execute this. This is my dependent feature. If you want to see the head, this is there. Now, if the total number of records that you will be seeing, that we are somewhere having somewhere around 20,800 comma 5, that basically means you have 5 features and 20,000 rows, right? Now, as you know, this is a text data, so we have to do some kind of text pre-processing. And in this particular video, what I will be continuing is, first of all, I'll go with count vectorizer. Now, count vectorizer is one of the technique which is also called as bag of words. Okay, and then you have TF-IDF vectorizer, then you have hashing vectorizer. Probably I will be uploading about hashing vectorizer in my YouTube channel to make you understand how it actually works. But for the implementation wise, right now I'll focus on count vectorizer. In my next video, I'll try to cover this too, because in this particular video, I'll be using multiple algorithms considering this. And since this is just a fake news classification, most of the time this count vectorizer will work well. Okay. So first of all, what I'm doing is that I'm importing all these things. This is for bag of words, this is for TF-IDF, and this is one more technique which is called as hashing vectorizer, which probably you may not have heard, right? So we'll try to use this in the later class. I'll try to make you understand. And one YouTube video for everyone I'll try to upload where I'll actually explain you about hashing vectorizer. Now, the first thing is that I'm dropping the NaN values from my DF. Okay. The reason why I'm dropping it, there are some NaN values, guys, and now if I execute this df and I'll execute this, now here you can see that my df.shape is 20,800. If I do drop na, and now if I go and check my shape from here, right, it is somewhere around 18,285. So hardly 2,000 records or 1,800 records are getting dropped because of NaN. So we'll probably go in that particular way, because this is a text data. If you have some NaN values, definitely you would not like to apply any feature engineering onto that. And anyhow, there's less number of NaN values that are removed. So I can basically create a machine learning algorithm by using this much amount of data. Then what I'm doing is that I'm just making a copy of df and storing it in a variable of messages. Then I'm doing reset index. The reason why I'm doing reset index, because guys, after dropping, right, some of the indexes will get dropped, right? And now when I just do this, see this particular example. If I write df dot head of 10 records, I'm just trying to check. And here you'll be observing that now from this, right, from this indexes, sixth record is missing, eighth record is missing. That basically means that that records had NaN values, right? Now I want to actually do the text pre-processing for all this. Now text pre-processing basically means that I have to remove all the unwanted keywords, any special characters. I just have to focus on the keywords over there, right? They are stop words also, I have to remove that. And there are a lot of other things that I have to remove, right? Special characters and all, because I don't require it to actually find out whether the news is fake or not. Okay. So because of that, what I'm doing, I'm just doing a reset index. When I do reset index, what will happen is that by default the indexes that will be getting generated, just let me just execute this. So if I do the reset index, now if I go and see my messages, okay, messages dot head, okay, head, and let me just display the same 10 records. Here you will be able to see that my indexes over here now are in order. Before it, the sixth index was missing, right? Now it has become in order. So now if I have in order, now what I can do is that for the text pre-processing, I can just put a for loop and it will go to each and every record, and then I'll pick up this particular text data. Before it was not possible because my sixth record was missing, right? Or I could have put a condition that if that record is not present, if that index is not present, I don't want that. Okay. So what I'm doing is that I'm creating one additional, I'm resetting the index. Now, this particular code that I've actually written is basically to remove all the stop words, to basically remove all the special characters from this particular text feature, right? So here you can see for that I'm using stop words, and for the the for the porting, stemming and porting is basically required. So I'm using porter stemmer. Okay. And sorry, this is specifically for stemming. Stemming basically means, suppose you have a word like learning, it can be converted into learn, right? And there are many more examples of actually making you understand what does stemming mean, right? So for that we are using this port stemmer, then stop words, and I'm initializing the port stemmer over here. This is my corpus. This is my empty corpus right now. Now what I'll do is that I will go and go towards the record, each and every records that are present inside this messages data frame, right? So I'm giving this particular loop for I in range 0 comma length of messages. The first thing that I'm doing is that I'm saying re dot substitute 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 all the character except small a to z and capital A to Z. Try to replace all this character with blank. That basically means if there is a special character, if there is such a character which is not belonging to A to Z or this particular variable, at that time you can consider that it will just get removed. Okay. So that is what we are actually trying to do. Then after that we are making all the text to lower, and then we are doing the split. The reason why we are doing the split, because after this we need to apply the stop keywords and the stemming, right? So because of that we are doing split. After doing split, we'll be having the list of words, right? Then for each and every word, first of all I have to go and check for each and every word in that review, in this review list. I have to go and check whether that word belongs to stopwords.english or not. If it does not belong, stop words basically means like if, I, can, he, she, which is not having much importance, right? So if it is not present in the stop words of English, what we can do is that we will just be doing the stemming of that particular word, and then it will get returned to the review in the form of list only. And finally I'm just combining all the spaces with the help of join function, and finally I'm getting my corpus list. So in short, in this particular step, what I'm doing is that I'm cleaning up all the messages, all the text with special characters. I'm making it lower, and I'm actually applying both. I'm applying basically the stop words. I'm filtering out with the help of stop words, and then with the help of stemming, right? So after this is done, you'll be able to see that how my corpus actually looks like, right? So once I execute this, what I'm going to do is that quickly I will insert a cell above, right? and I will actually show you what is my corpus. My corpus is basically a list in this case, right? So this will take some time to execute because there are a lot of words. So it will definitely take time. There are a lot of 18, I guess 18,000 records, right? 18,285. So don't worry. Anyhow, it will get executed. It depends on the speed of your laptop also, and probably it will take time, another 1 minute, I guess, to execute. But let me just go ahead. Once I get this particular corpus, the next thing that I'm going to do is apply the bag of words, right? Now, bag of words, basically the library that I'm going to use is something called as count vectorizer. And you know that I have imported that count vectorizer somewhere here, right? So what we are going to do is that we are going to quickly import this count vectorizer, and then we are actually saying that from all the words, okay, from all the words, because when I applied the count vectorizer, there's so many words as a feature, but I'm saying that take the most 5,000 frequent occurring words, and I'm also giving an ng-gram range of 1 comma 3. That basically means that it will take the combination of one word, two words, and three words, right, and as a feature, and then it will basically apply the bag of words. So I hope you all know about the bag of words, and it is pretty much clear about how the bag of word actually works, right? So we apply the bag of words with ng-gram as 1 comma 3, and then I'm actually doing the fit underscore transform to this particular corpus, sorry, not to this corpus, to this corpus which I'm actually creating, and then we are actually converting to an array. So when we do that, you will be able to see that we are actually getting the same number of records, but now we have 5,000 features. Okay, 5,000 features. So all these particular words, when we have actually converted into a bag of word, we are considering 5,000 features, right? Then after that, I'm going to consider my output feature, that is message of label. Okay, I get my output feature. Then I'm just doing a train test split. Train test split is basically, now I got my independent and dependent feature, and because of that I'm just doing my train test split. In train test split, I'm basically giving a test size of 0.33 and some random state value. Okay, so here I'm actually getting my train test split. Here you can see that I'm getting my x train, x test, y train, and y test, right? Now the next thing is that if you want to see, all the features name by the combination of ng-gram, right? Now this is one example. Suppose I get all the feature names, the top 20 feature names. You can see over here abandon is taken, abc news has been taken, all these things are taken. Now abc news is basically two words, right? So in ng-gram I gave 1 comma 3, right? So it will take the combination of one word, then two words, then three words. Okay, so if you want to see one more example of three words, here it is, access pipeline protest. So this is the combination of three words. You can also see Abbas, New York is another combination of three words. So these are all my feature names. Now, based on this stuff, now you can see that this is my corpus. It has got executed. So all these are my corpus. It has got executed successfully, right? No problem as such. Now, one thing that you need to understand over here, if I write get underscore params, you'll be able to see that whatever algorithm we have actually defined over here regarding count vectorizer, all this particular information will show. It is basically giving analyzer as word. Okay, you can see the ng-gram range is 1 comma 3, minimum underscore df is 1, maximum feature is actually 5,000, lowercase, yes, it is true, input content, what is the kind of data type, it is actually converting it to, right? The vectors are getting converted into int64. So similarly, now these are my get params. Now what I'll do is that I'll show you how my X data set looks like, or my data set actually looks like. So here I've converted that into a data frame, and my columns are actually present inside my count vectorizer dot get features underscore name. So when I do that, and if you see over here, you'll be able to see your data set looks something like this. So all your features are something like abandon ABC, this. Uh, these are all your feature name. These are the values. One, if it is present in this particular sentence, in the fourth sentence, suppose this particular stuff is present, you'll be able to see it. Let me just verify it. Probably you can go over here, 0, 1. Okay, I'll just write 5, right? Which sentence was that? 0, 1, 2, 3, 4. Okay, fourth sentence, I guess. Yes. So let's see whether in the fourth sentence that thing is present or not. Where did it go? Yeah, so here it is. I'll just go and see, verify in the corpus whether that fourth sentence is there or not. Now if I see over here, this was the word absolute. So here you will be able to see Okay, this is probably fourth. And fifth, I think I found out, right? Absolute. Where is absolute? Okay, I'm not able to find it out. Why? 0, 1, 1, 2, 3, 4, 5. Oh, okay, it is of X train because it got converted. It got converted in the split, right? So because of that, it is not coming up over there because this messages you see over here is after. Sorry, this corpus. After that, we are actually splitting it over here, right, and converting it in an X and X train and XY. So because of that, we will not be able to see it because we have done a train test split. But just try to understand that that will be in the same order like how we are defining over here. Now what I'm going to do is that my data set looks something like this, but anyhow, I have converted that into my X-train and X-test. Now I'll train my model on this particular data and try to fix it. Now this is a plot confusion matrix, guys, a custom way of plotting a confusion matrix. All the details of this is basically given in the link over here. How do you write it? But all the thing that we have to do is that we have to give our confusion matrix. We have to just specify our classes. Okay, and once we are able to do it, it will automatically create it. And again, no need to by heart this because it is already present in this particular HTML file. Okay, now the first algorithm that I'm going to use is something called as multinomial naive Bayes algorithm. So from sklearn.naive Bayes, import multinomial naive Bayes, and remember for text data, multinomial naive Bayes works well. And this is also supported for multiple categories of output. Okay, so here I'm creating a classifier of multinomial, and here I've not used any features, guys. Because I'll show you how I'll perform a hyperparameter tuning on that. There's a value called as alpha. With the help of alpha, we'll be able to do it. I've imported some of the libraries like from sklearn import metrics, numpy, iteration tools. Okay, now this classifier that I've created, I'm just going to fit it with extra train and ytrain, and after that, what I'm doing is that I'm saying classifier.predict on X test. I'm also computing the accuracy score, and then I am actually getting the confusion matrix, and then this confusion matrix I'm giving it to my function, which is plot confusion matrix over here. So this is my function where I'm actually specifying it over here, and this is my CM value. My classes are fake and real that I'm giving as a label. So once I execute it, you'll be able to see that we are getting an accuracy of 90%. And this is my confusion matrix. You can also see um, this is my true positive, this is my true negative, whereas my false positive and false negative are very less when compared to this. So we are getting an accuracy of somewhere around 90%. Then I thought of doing some more things, and there is an algorithm which is called as passive aggressive classify algorithm. This algorithm also works very well with text data, and probably I'll upload a video about this particular algorithm theoretically, how it actually works in the theoretical way. That I'm going to put up in my YouTube channel, and then you'll be able to understand a whole lot of things from that, right? But the implementation wise, again, it is present in a linear sklearn.linear model. And this is also a regression. This is also a kind of algorithm which works on uh, text data very nicely. Okay, so here I'm taking this passive aggressive classifier. I've given the iteration as 50, the first parameter over there. Then I'm doing dot fit. All the steps are same. Then you can see that I'm getting a 91% accuracy, right? Now, guys, you may be thinking, what is this particular algorithm? This algorithm is basically used for text data. Just wait for some days. I'll be uploading that video on my YouTube channel. You'll be able to understand that. Now here I've got 91%, pretty much good. Now multinomial classifier with hyperparameter, what I'm going to do is that I'm going to take this alpha value. Now this alpha can be changed, it can be taken with different parameters. That is what hyperparameter actually says. Now what I'm doing is that here I've initialized a classifier, okay, just a normal multinomial naive Bayes classifier with alpha as point 1. This is the default value. Now what I'm going to do is that I'm going to say that from alpha in np dot range, so I'm saying, so take the alpha between 0 to 1, where you are changing the value with respect to the time step, with respect to the step point 1. So at the first iteration it will be 0.1, then in the second iteration it will be 0.2, 0.3, 0.4, like that. And internally I'm creating a sub classifier with multinomial naive Bayes with this specific alpha value. then I'm doing xtrain and ytrain fit, then I'm doing the predict. I'm saying that if my here I'm computing the accuracy score first of all. Now if I say that my score is greater than the previous score, okay, previous score is basically this, that initially I initialize it to 0. If it is greater than 0, then what I'm going to do is that I am going to basically consider this as the subclassifier. I'm basically saying that just replace my classifier with the subclassifier, right? Just replace it because I know that this particular subclassifier will be working well, and I'm doing it for each and every check of this, and this will get iterated for n number of times, and finally you'll be able to get the best one. So here you can see that with different alpha values, you are getting a score of, suppose of alpha 0.9, you're getting a score of this. For alpha is 0.8, you're getting a score of this. So like this, you're getting all the alpha scores, and you can actually select the best score out over here. And definitely the best score looks with alpha zero point 0.3, I guess, because it is showing 0.90, 0.9024, or you can also say this one 0.9025. So yes, here you are able to get it. Now, when you are actually applying multinomial classifiers with hyperparameter, make sure that you select with different varieties of alpha value, and it can be between 0 to 1. Okay. Now, one more thing that I wanted to show you, just by looking at the vectors, right? How do you determine which is the fake word and the most real word? Okay. Now, first of all, I'm getting all my feature names from my count vectorizer. Then I'm getting my coefficient value. See, coefficient value usually have different kinds of values over here. Now, since I have applied, you can see a multinomial classifier with hyperparameter, there will be different coefficient value that will get selected based on the problem statement. Now, what I'm doing is that I'm using, now remember, this particular value will also be having varieties of values. Okay? The most negative value is basically the most fakest value, fakest word. Okay, the less negative value is basically the most real word. Now if I, and trust me guys, if I go towards the lower value of the negative, lower value basically means like minus 20, minus 30, right? That basically means, suppose if it starts from minus 10, that is the most fakest word that will be available over there. Now if I take this particular example, you can see over here I'm doing a zip of classifier of coefficient of 0 and then feature names, and I'm just saying that you make it this as a reverse is equal to true and get the last I mean the biggest 20 and first 20 words with this particular value. Now you can see over here the lowest value is basically not lowest, the biggest value in the negative terms is minus 0.400. Then all the values are actually lower than this. So as we are going in this particular way, we are basically saying that these are the most real words. Okay, these are the most real words. But if I just reverse it, if I remove this reverse is equal to true, it is going to display the biggest value in terms of negative. This is not the biggest value, the lowest value in terms of negative, and this basically indicates that these are my most fakest words. Okay, these are my most fakest words, and you'll be able to see that these all values will be decreasing, and then it will continue and join this particular chain. Okay, and then that basically indicates that from most fakest. Now see, if I just make it to 100. Okay, now here you'll be able to see that after some time this particular, again it is just showing the same value because there are many values which are having a lot of, suppose I say 3000. Okay, 34,000. Okay, still there are so many words over there, so probably it is getting the same value. Okay, now it changes, I guess. Yes, now you see after this particular word, it has now changed, right? These values become a little bit less. Academy, a clue, and still if we go more, if I take 5,000, okay, let me just take 5,000. Now if I take 5,000, you'll be able to see still the different values. So over here you are seeing, you are able to see again the same value again. After this again it will reduce, and finally it will come in this particular manner only. Okay, this will be inverted over there, and finally the last value we'll be getting is this. So I hope you understood this. Just try it by yourself, you'll be able to understand a lot. uh, One homework that I want to give you is that just try with TF-IDF vectorizer and hashing vector, and forget about hashing vector. I'll just create a video on that. That will be my second tutorial, and focus over here. I'm going to, right now I'm using machine learning algorithms. Then in the upcoming lessons, I'll be using artificial, not artificial, RNN techniques or ANN techniques to actually solve this particular problem, right? So I hope you like this particular video. So I'll see you all in the next video. Thank you, one and all. Bye bye.